Hi everyone, this is Ying from IBM. So today I'm going to talk about the Presto C++ Iceberg support. So the content. So I'll first introduce what Iceberg is, but I think most of you have already known this popular table format, and then we'll talk about our status in supporting this table format in IBM. We'll briefly introduce the design and the implementation, and we'll also present the performance improvements we did on Presto C++ read, and also we'll talk about the Iceberg insert implementation and future work. All right. So I think most of you have known this Iceberg table format, right? So basically, it is a table format for us to manage all the data over time. Like we can do insertions, deletions, and with full ACID compliance. It also supports schema evolution and time travel, so we can go back to a certain timestamp back in the past. And it also has the query performance in mind when the creators was originally designing this table format. For example, it avoided the expensive directory listing. And also, it has its own ways to keep the column statistics to eliminate files more efficiently. So currently, the Iceberg community is trying to go native. So they're trying to develop Iceberg C++. And here we, on our side, we're trying to support this in Presto C++ in native to support this table format in full. So I think there is a pretty good opportunity for both communities to work together. Yeah. So currently, in our IBM Lakehouse, we have supported the read of both V1 and V2 tables. This includes the tables with positional delete files and equality delete files. And our team has done pretty good, awesome work to improve the scan performance from last year. And we also supported the insert into this year. So it supports both partition and non-partition tables, and some basic partition transforms like year, month, and day. So we have updated the Presto documentation in the Iceberg connector section. So you guys are welcome to check out the latest support status, like what table properties are supported, what session properties are supported, and what metadata columns you can query for Presto Java and Presto C++, respectively. Okay, so let's first quickly recap the design and implementation of the Iceberg read. So for Presto, the architecture is like there is one or several coordinators and a bunch of workers. So when the query comes in, the parsing, planning, scheduling are done in the coordinators. So this includes several steps. So in the planning phase, we will send the request to the Iceberg catalogs to get the table metadata. And then during planning, we added a special rule that pushed down the filter to Iceberg tables. And then with all this information, we send this scan task to Iceberg library, where it will return the scheduler, the split manager that what splits that we should read and send to the workers. So here is where the partition and file pruning is happening. So it's done by the Iceberg library. And this part is actually all in Java. So I think, sorry. And then once the splits were generated, the scheduler would distribute them to the workers, where the worker is backed by vlogs, where local planning and execution happens. All right. So a quick recap of how the precision deletes are implemented. So it's so on vlog side, the read is done by Hive connector. So it's a Hive data source. And the Iceberg specific operations were done in Iceberg split reader and precision delete file reader. So this happens when you're adding a split to the Iceberg split reader. It would create the row reader for the base file, and also create the precision delete file readers if there are any precision delete files. And then during the real read, which is implementing in the next function, it would ask the precision delete file reader to read the deletion positions, and the result will be sent back to the base file reader as a mutation object, and it's actually a delete bitmap. And this bitmap will be pushed down to the reader as an initial row set. So they will be exclusive from the very beginning, meaning that we don't have to decode these values and put them into vlog vectors. Yeah. And last year, we supported the reading equality delete file as well. So so Iceberg supports these two different delete modes. So precision deletes, where you have the positions of each rows being deleted. And the equality delete file actually holds the value. And so it could be a single column or multiple columns. So these were Iceberg identifiers. So in implementing this, we will translate them into domain filters and filter functions. So if it's a single column, so we'll transfer them into a not-in filter with a special handling of nulls. And this can be pushed into the reader. Yeah, and multiple column delete files, or there are, well, yeah, so multiple columns will be created as a filter function, as a remaining filter that the reader evaluates after the read is done. So you can see in this chart, we have a new equality delete file reader, which does the read and the interpretation of these values. Yeah. And so with these basic implementations, we did some performance testing last year, but to our surprise, the Iceberg connector, Iceberg in Presto C++ is like 45% slower than the Hive connector in Presto C++. So our team worked really hard, and we have fixed this regression. So when looking at this regression, we firstly noticed a very long Presto query planning time, like in seconds or even in minutes. And also we noticed the plan difference between Iceberg and Hive. Okay, so then our brilliant optimizer team, mostly Zach and Ritika, so they made a bunch of fixes. Oh, I forgot to mention that the first thing we noticed was that the scan planning time was really long because the Iceberg library keeps reading small files, in many times. So for a single query, it might be reading a small file for dozens of times. And this is very slow. So to fix this problem, so we introduced manifest file caching in Presto repo. And also, we also added the statistic file caching. And then the optimizer team come with several statistics and the cardinality estimation fix. So at the end of last year, so we were able to see the plans were exactly the same between these two operators. And then we start noting that there are some execution time regressions. So Zach first noticed that the split size is much smaller in Hive operator than Hive. So he introduced session property Iceberg target split size bytes, and also we support the table property read split target size that you can specify the split size, and this helps the problem a little bit, but not all. And then we noticed there are the skew problem was pretty bad in Iceberg connector. And so this was because the difference between Hive and Iceberg. So I think Andre made some fix in the Hive connector. So we ported that over. So then the skew was much better. So so for now, we can see these two connectors were almost the same. So the run-to-run variation is within a few percent. Yeah, all right. So next, I'm going to talk about the insertion implementation. So with insertion, so everything else is very similar to Presto Java, except that the writer part is done, in the worker in Velox. And in our task, because we use Parquet, so this would default to the Parquet writer, which was originally copied from Arrow. So this is like the whole process is like. So similar as read, the split will be scheduled to the worker, and worker would do local planning and create the pipelines drivers, which contains the table writer operator as a data sink. So in the add input call, the Hive data sink would call append data, which would calculate the partitions, bar key IDs, and so on. And then it would, so we introduced the Hive Iceberg data sink, which subclassed Hive data sink. And with this custom implementation of split input rows and ensure writers, which is, we do Iceberg specific operations, like we get the writer parameters from the Iceberg insert table handle, like the write directory, file format, table name, and so on. And then the initial writer would create the writer, the actual writer, during which partition data will be calculated. So because Hive and Iceberg handles the partitions quite differently. So for Iceberg, it writes every data column. Every column, no matter is partitioned or not partitioned in the data file. So we have to remember what the partition values are. So we collect them during this moment. And then the table writers, the actual data writers like Parquet writers, Dwarf writers will actually do the write work. And at the close time, the commit data will be created. This includes the data path and the size and the statistics and so on. And this commit data will be sent back to the coordinator, which we handle it to the Iceberg library to do the final commit. Yeah. Okay, and here is some performance numbers of the insertion. So we use the TPCH 1 terabyte data load from the TPCH connector. So we run this in Presto Java and Presto C++ in both Hive and Iceberg connectors. So we see that the C++ implementation is about 10% faster than the Java. And this is actually coming from the TPCH connector. So as you can see in the right chart, it comes from the scan, filter, and project operator, which is incurred in the TPCH generation. So the native TPCH connector is about 2 times faster than the Java one. But the right part is not particularly faster, which indicates future improvements, opportunities. Yeah. All right. So we're doing some testing work currently. So this includes like adding more end-to-end tests in Presto. And we're also building the pipelines for these 2 major benchmarks, which includes the data loading phase and data maintenance phase. Both includes the inserts. So we have built this into the pbench tool, which is also public, available to the public. And also in the next, we're going to port over the Iceberg Presto tests into our Presto repo. And at the same time, we're working on the unfinished partition transform. And sorting is also something we are working on. And in the future, we want to support more metadata tables and columns. So far we support 2 metadata columns in reading, which is path and I forgot the other one, but so these 2 are constant columns. So if you want to read a row number, for example, or which row is deleted, then that needs additional work in Wheelock's part. And also, we want to make sure this equality delete file reader works for gluten as well, because we use the logical expression evaluations, and some of these logical operators are different between these 2 engines. So we'll need to generalize these. Yeah. And also, there are some data types not supported yet. that we need to build the filter, the expressions for these data types. Yeah, and next we're going to work on delete. So we're going to support both writing precision delete and equality delete. And more performance optimizations in the Parquet reader and expression evaluation and Parquet writer. Yeah. And I'd like to thank our team in IBM. So they come from different teams in like execution and optimizer team. Yeah, so together we made this work. So special thanks to them. And also special thanks to Meta folks who help us reviewing the code. Yeah, so that is the end of my presentation. So any questions?